No, it's workshop time. Today with us we have Marta, head of BD and DevRel at Subquery, and she will be telling us about multi-chain indexers. Marta, take it away.
Thank you, thank you. Hi everyone. Great to be here. This is my, I think, fourth sub0, one of my favorite events, and I'm super happy to see it in a new version, revamp of sub0, great vibe, such a great energy, and I'm very happy we have a chance to be here and talk about such an important thing as multi-chain indexing, which is one of my favorite features of our solution, but also it's not only my personal opinion. There is a clear demand and a great need among builders to get a few issues related with blockchain data indexing sorted, and multi-chain indexing helps with it big time. And this is the topic of this workshop. And yeah, I run BD and DevRel at Subquery, and I'm a proper person in a proper place, I would say. So for the agenda, I want to tell you a little bit about our solution and also spend some time discussing how indexing really works. And we'll do the step-by-step guide and tutorial. And the aim for this whole workshop is for you to understand what indexing is, but also be able to use Subquery to index data across different chains. And of course, we'll do a demo time. I will go to the code base and show you how our project works. And also, there is a challenge. I also love this about this edition of sub0, that really very much engaging and is very proactive oriented. So we have here challenges, and after every workshop, builders can complete it. So we do have a challenge also for you, and then you can gather points and win some great prizes. So we'll discuss the challenge as well. And then I will wrap up discussing what's next, so what you can do with all of that knowledge, how you can, what other products we have to help you get more decentralized and help you access data in other ways. So this is the plan. Just briefly, I want to tell you a bit more about Subquery and our mission. We are, I think, getting closer to 5 years operating, so this is a long time in the Web3 space. And we started in Polkadot. We are one of the Web3 Foundation grant receivers, and we are very much deeply rooted in Polkadot. So this is also a perfect place for us to be and contribute to. Our mission is to help builders solve a lot of problems related with accessibility to blockchain data, and essentially allow them to get fully decentralized, and also allow them to get access to data in a faster and more efficient way, so that they can focus on what they're building. So they can focus on the end functionality, on the amazing product they're launching, and don't worry about this tech stack thing that is not so hot, but it's super important. And why not outsource it and use a tool that somebody built for them? And this is our mission, to help really push the decentralization, solve a lot of issues around Web3 infra not always being fully decentralized, and also help builders access data on-chain. And our core product, and also the topic of our workshop today, is our open source SDK. This is our indexer, and with that, we want to help builders get access to data, and also help them build applications that are not only intuitive, modern, but super performant, so that builders in Web3 space and their applications can really compete with Web2 space, also when it comes to the performance, right? So essentially, when do you want to, for instance, build a mobile app and you want to have a wallet and, let's say, display all the transactions, the history of transactions, it's not that easy how it is with centralized databases. Think about the blockchain as a metaphor that we often use is a book. So if, for instance, you want to find how many times certain character in a book used a certain word. What you need to do, go page by page, verse by verse, and just count them. This is not very efficient and fast. And this is somehow similar if you want to obtain data that resides on the chain. You have to go block by block, check everything. It's not a rocket science, but it takes time, and that's the problem, right? Time is gold, and this is something that we are really helping builders to achieve. And I will also speak about that when we go to the multi-chain indexing, but it's not only the fact that you need data fast. There is a bit of rocket science or something which is more complicated when it comes to multi-chain indexing, and I will tell you a bit more about challenges related with multi-chain indexing, because it makes it hard for developers. So subquery mission is to really help them focus on the end functionality, and we do really care about developer experience, but also about the end user experience, right? So that would be it. And subquery is like end-to-end blockchain solution, indexing blockchain solution. We will focus on the open source indexer today, but we also offer managed services and also decentralized marketplace subquery network to host your indexer in. And I will mention this later in a greater detail. But going back to indexing. So how our solution looks, what happens behind the curtain is that indexers really shine, and subquery as well, when you narrow down your use case, when you know what type of data you want to index, right? So you're building NFT marketplace, you're building analytic tool, DeFi application. You are after a certain data on a certain chain, right? And within subquery, you set up filters which allow you to focus only on this data. Subquery will retrieve it from the blockchain and save it in a Postgres database. And we will also provision a GraphQL API endpoint for you to query this data. So developers using subquery, they don't have direct access to database. They use GraphQL API endpoint to query the data. The data they will receive in their application layer is exactly what they want, so this fits their use case. And also the format of this data is exactly as they shaped it. So they have a full control over the end result of the query, how the data is shaped, how the object is named, what properties it has, how objects in the database are related to each other. This all is in a full control of the developer. So this is also something that we really thrive and really aim to do, to give this control to developers. Don't only provide access to some ready-made data sets, but give them a tool that they can really customize, that it's flexible, and give them a chance to have a super unique use case. And and this is what really happens. And we, as I said, we've been working on this for more than 4 years, and we support 230 plus networks across different ecosystems. Every network is another ecosystem with a lot of builders there and applications. So we do have a lot of customers and partners all around from different niches. So from analytics tool to NFT marketplaces, DeFi projects, chain explorers, mobile apps, and on and on. If you need data in your application that is on chain, you can definitely use subquery to get it indexed, if we support this network. And just a super quick overview around a few features. So open source, super important for us. We'll always remain open source. We have a very vibrant and robust GitHub repository. I will share links to it later, with a lot of templates, hundreds of templates for you to choose from. For every network that we support, we have a starter project, so you can easily initialize it using our subquery CLI or fork the code from our repository, and it will be working, right? With one command, you will spin up your own indexer, and you will get some data index, and you can then adapt it to your needs and easily edit. And this will always remain so. It's easy, we use Docker, it's super simple, it's written in TypeScript, it's highly customizable. A lot of parts of the project you can change and adjust to your needs, and some of those I will show you today. It's fast, feature-rich, a lot of features that we don't have time to discuss today, from real-time data indexing, historic state data indexing, non-deterministic indexing. We really have like 20, 30 developers working on this constantly for 5 years, right? We have to bring more features, and we partner with a lot of customers and learn from their demand and feedback. So there's a lot of cool stuff that you can do with subquery. I really recommend visiting our docs. And it's, of course, multi-chain. That's what that's our topic for today's workshop. And it's flexible. By flexibility, we mean that in the project in the moment when you receive data from the chain, you are able to use external API calls, external libraries, trigger some other functions in other parts of your applications portfolio. Essentially, this brings a lot of possibilities and more uniqueness to subquery project. I will tell you more about it when we will look at mappings file. This probably will make more sense then, but this is pretty awesome as well. And I already mentioned 230 networks. Here is the QR code and also link to our website where you can check the list of all the networks that we support. Of course, Polkadot parachains, a big number of them, Cosmos zones, EVM-compatible chains, Near, Avalanche, Algorand, Flare, and more and more and more. And please also reach out to us if you represent a network, and get in touch with us so we can bring support for your chain as well. And yeah, for those who want to follow the workshop, those would be the dependencies. Probably all the builders here have Node.js, and most of them probably Docker, but I also encourage you to install subquery CLI if you want to follow the workshop. But if it's not a good setup now, it's not a problem. I am sharing a lot of docs and step-by-step guides here as QR codes and links, so you can check it out later. It's also fine. So how subquery indexer work? So I've mentioned previously that it helps you obtain data from the chain, and it's highly customizable. You can think about it as your custom API for your application that provides you with the data you exactly need. And when you use subquery, you will initialize it after you download subquery CLI with a simple command subquery init. And this command will then show you the network family you want to get your project initialized. Let's say it's Polkadot, and then there will be a bunch of parachains that you can choose from. And you will end up with a scaffolding, ready-made project that is indexing some data. Maybe it will be simple, like transfers, approvals, transfer account balance, something very simple, but to get you started, right? And as I said, we have hundreds of those examples. And then the next step, what would you do, is to actually build. So this is not a no-code solution, obviously, right? You get your scaffolding, you have your project there. It will be working if you just spin it and initialize it. But if you want to build it and adjust it to your needs, you will need to work with 3 files. So this is schema GraphQL file where you define objects in the database and the relationship between them. It's like a reflection of the tables in your database. You will also configure filters and endpoints in the manifest file. So this is like a configuration file entry level into the project where you answer question, what do you want to index and from which chain, right? So that would be the manifest file. And then we have a mappings file where the magic happens. So this is where all the data is transformed. The data coming from the blockchain in a raw format is transformed into the shape you defined in schema GraphQL and saved in database. So those would be those 3 steps, and we'll go through them also looking at the code base. And then a deeper dive into how schema GraphQL can look. So this is one of the files I've mentioned. Here you can see some of the examples, pretty simple objects. Of course, projects will differ from one to another, right? You can have you can imagine very complicated projects with a lot of schemas and a lot of entities, but they can be also very simple. Essentially, this is what you need to remember. This is the end result of your query. So this is how you want to receive your data in the application. Developer is in a full control of it and can define how the objects are related to each other, what properties they have. And then I've mentioned in manifest file, we will configure the endpoints, we'll provide chain ID, ABI file, and also, most importantly, filters, narrowing down our indexing use case, defining what do we want to exactly index, what type of events, logs, transactions are interesting us, are of interest to us on chain. And the mapping functions, so this is where the magic happens. This is a part of the subquery code where, which is triggered when indexer finds a proper event on the chain. This function is executed, and the logic here actually populates the properties of the object, creates the object, saves it in the database. And at the end, you can start your indexer. You can, we use Docker for it, and with the simple command yarn dev, you're able to get it started. And at the end, if you will use your local machine, visit localhost 3000 and get, you will see a GraphQL playground, and you will be able to query the data. And this is actually part of the challenge that I will ask you to do, is to actually fork a project from our repository and execute this command and query some data and show me that you did it. So that would be the part of the workshop. Okay, so now let's go to demo part. So we are here to talk about multi-chain indexing. So far I was discussing mostly indexing in general. And then when something is multi, it often means it's more complicated, and it's also the case with indexing. So we have, there is a rise of a blockchain, blockchains that are application specific. They're very different from each other, right? We have parachains in Polkadot, zones in Cosmos, we have optimism stack, and so on and so on. And we have every chain has some specifics, and between those ecosystem and environments, developers will encounter some issues. There'll be different RPC interfaces, different smart contract environments. Also, data will be shaped differently, will be formatted differently, and this requires some knowledge and skill to actually understand and be able to index this data. At the same time, this poses a difficult challenge, and at the same time, it's also super important and more nowadays to actually have applications that are cross-chain. There is more and more value which is like seen from chain-agnostic applications, and big, really successful applications that made a lot of waves and even cut through the noise to Web 2 space are actually chain agnostic or cross-chain agnostic. And more, cross-chain deployment is necessary even to be treated seriously. And this is a difficult problem for a developer. What it means really, that for every chain that this person or the team wants to index, they will need to set up a separate indexer. And then they will get data in separate databases. They will be in different formats. Then they would need to do some type of a unification work, merge the databases, do a wrapper around it. Why? It's not necessary. You can make it simpler, right? And this is what subquery does. So we introduce multi-chain indexing to allow builders to get data across different environments, but in one database, and they will be queryable through one endpoint, right? So you have your few parachains, but you can also have EVM-compatible chain and substrate chain and Cosmos zone, and you want to index data from all of those networks. You would be able to do it in one database and then query it through one endpoint instead of having a few different indexers, or even dozens of them or hundreds, because it happens that sometimes applications really need a lot of chains. And behind the curtain, so the developer experience is still one database and single API endpoint, but behind the curtain, subquery does use different indexers for every chain. This is represented also in different manifest files. So for multi-chain projects, when you use subquery, you will have manifest file dedicated to every chain. The manifest file is the configuration file. We will see them in a second. But the schema, where you define objects in a database, and mappings file, where the data transformation is happening, this will be a single file that covers all of the different networks, right? So a simplified solution for a developer. Some of the use case you may think of, like, for instance, crossing cross-chain messages coming from parachain to a smart contract residing on another parachain, which is EVM compatible. Again, you would have this problem, minimum 2 indexers that you would need to work with, and that's something that we wanted to help with. And this is a project that we will look at in a second. So this is multi-chain project indexing data from Polkadot, Kusama, and Asset Hub into single database. The first QR code and the first link is linking to our starter project. So this is the project that we are sharing with you, and I invite you to fork and to give it a test run. And below, another link and another QR code is to example article. That's a longer blog post discussing step by step what we did and how, with a lot of useful resources to more technical documentation if you want to dive even deeper into multi-chain. And then the last thing before we go to the code, I want to mention this. This is something that differs a little bit when you start developing a multi-chain project with subquery from a single chain project. So you would need to enable multi-chain in the node. That's easy. Schema file is still the same, one file. Manifest file, as I said, one manifest file per one chain you're indexing. If it's 10 chain, that will be 10 manifest files. And then also one subquery multi-chain YAML file, which is actually a reference to all those manifest files that you will have in the project, right? So it's a list of references. And that would be it. I invite you also to look into this guide, multi-chain guide. It shows you how to develop multi-chain projects from scratch, starting from a single chain project, how to do it to have a multi-chain one. And also what's cool, you can use actually subquery CLI command to automate the whole process and get the scaffolding ready from Cosmos protobufs or from ABI file. We'll be able to, with a one command, to get the scaffolding ready, and much of this work will be done for you already. So that's pretty cool. And let's now see the code base. So this is the project I was referring to. This is pretty much how all the subquery projects look. But I want to start with the subquery multi-chain reference file. That's what I mentioned, right? We'll just reference all the manifest files for every network we index. So in this project, we index Kusama, Polkadot, Asset Hub. So we have 3 manifest files, and they are listed here. And what's also important to show is schema GraphQL file. So this is the end result of the query. Those are the objects in the database of this project. And as you can see, we have a few interesting things to look at. So we have account and trust transfer. Those would be quite self-explanatory. But this generic substrate account, that feels weird, right? What is it? We want to index data across different networks. We want to see how different accounts are sending and receiving some transfers. And there is something like a substrate generic account that can be retrieved from the data, from the transfer data. And this is different than the address of this account on Polkadot, or it's different from the account address on Kusama. And then you will be able to see at the result, as a result of it, how a a substrate generic account is actually sending and receiving those transfers across different networks, right? And that's why it's a separate entity here. And yeah, I think that makes sense. If there is any question, you can always stop me. You don't have to wait until I'm finished. And then let's see the manifest files. So let's look at Polkadot. This is the configuration of the entire project. So this is your entry point. This is where you define what do you want to index and from where. And those manifest files, for most of the cases in multi-chain project, will be 95% the same. What will differ will be the chain ID, the endpoint, and maybe sometimes filtering, right? If we have very incompatible chains, then there'll be methods or filters will have different names. But that would be a small difference. In this example, those projects differ only in the network area, so this is here, and in terms of endpoints and chain ID. So as you can see here, we provide the chain ID, so we want to point to a chain that we want to index. We have an array of endpoints. Everything is editable here, right? So you don't have to use those, and you can add plenty more. And in the data sources, this is where you narrow down your use case. This is where you point to the start block from where you want to index. It doesn't have to be the first one. It can be any other that makes sense for your application. And then you narrow down what type of event, log you want to index. And important thing here, as you can see, the handler name is handle Polkadot event, right? Isn't it too small? Maybe a little bit. So this one. You will find a corresponding function to this handler in the last file I want to show you, mappings file, which will be executed when indexer will encounter a data on the chain that meets this filter, right? So it will then execute exactly the same function in the mappings file. And then just to show you that I was not lying, and Kusama manifest file is pretty much similar. The difference will be chain ID, endpoints, and of course the name of the handler. Okay, I lied. That's another difference. So the handler for this particular use case, because we want to keep the information that this transfer was in Polkadot or in Kusama, they have different names. We'll clearly show it, how it will see it in the mappings file. But that would be it. And then let's go to our mappings file. So this is the coolest of them all. So what's interesting here, as I promised, we'll have two functions that we already saw corresponding handlers of, right? So we had the handle Polkadot event, and we had the handle Kusama event. And we have them as a separate handlers because we want to preserve this information that it was Kusama or Polkadot network. And we will then pass it as an argument in the next function. As you can see, both of them will use handle event function, and we will pass the information which network it was in here. Then what happens is that we will, to get the generic substrate ID, will perform some actions using the data coming from the chain and other functions within this file. So for instance, to create the from generic address, we would need to use function decode address, which, where is it? No, sorry. So in this place, yes, in this place we are decoding the data from the chain, and we are able to retrieve the substrate generic ID and then use it in the next part of this function. What happens here, we also want to ensure that this account actually exists, so we are using promise for it, and we are using the generic address from and to within it as well. And then what's happening as a next step is that we are populating the transfer object properties with the data from the blockchain or data already transformed within this file. And of course, we need to update balance of the account, because this is also something that we are indexing within this project. The update balance function is here. We just want to make sure that whatever we are sending or receiving, we keep track of those changes, and we know how much money, how much tokens stay in there. And that would be it. This is a file that allows you to construct a unique logic for your application and transform the data as you need, so it fits your use case into the greater detail. And I also mentioned before that subquery is flexible and it's super cool. It allows you to use this API, external API calls or libraries. This is the place where you can do that. So essentially, you can enrich the data on chain with any other information you think is relevant for your application. So let's see you're indexing, for instance, some swaps, and you want to compare the result of them, those swaps with prediction from CoinGecko. And you want to know if they're matched or mismatched, and by what number, the prediction. You want to know it for some reason in that moment, right? You can do that. So you can have an object, you can have a property in your object mismatch the CoinGecko prediction or not, what was the CoinGecko prediction for the swap, and save the information which is not coming from chain within your database if you decide this is what you need and this is what would be useful for your application. And this makes subquery unique, and a lot of projects built with subquery super interesting because we allow this flexibility. Okay, and what would happen next is that we would spin up the indexer using yarn dev command, just one command that will build all the application and spin up Docker engine. And what you will be able to see if you then go to localhost 3000 is a GraphQL playground and see some results of the data query. So essentially, we want to execute a query from the database and get some answers. This is an experience that developer will have at the end of this whole process. What we want to do is access to data, right? And I will show you this. Exactly this project is deployed on our managed services. So this is this repository, and it's indexed. It's live, and you're able to query the data. And of course, this is all editable. There is also a lot of instructions on GraphQL if you need some help with data query, and you're able to get some information from there. And I really recommend you visiting this and playing with it, with this project and also with the query. And please submit this as a part of the workshop challenge if you want. And yes, also one other interesting example that I can show you, the same project. So this is a part of an article that we've written. Why I cannot? Okay, I will show you it differently because I also have it as a screenshot. So essentially, you are able to. So this would be your query, and you are filtering through an address. And this is it. And then you are able to, I'm not sure if it's not too small, but this is a receiving address. And this is it in the full form, because here it's like, it was too small, and I had to squeeze it in one screen. But essentially, you are able to see that this is same address here, and different transfers on different networks, right? So this is your end result. So you can track the transactions happening across different chains. This weird thing here, this is a construction of ID, which is constructed from the network name, block height, and event number, right? So to make it unique, so we don't have conflicts in the database. And the rest, I think, is pretty self-explanatory. Okay, so those would be the query examples. This is a link that sub0 team asked me to provide here for you guys if you want to submit a workshop challenge. This would be to give it a try, fork the subquery project, take it for a ride, and show me some data queried in the playground. So the screenshot of the data query in our playground local, on your local machine, local host 3000, would be the proof of the participation in the challenge. And I've mentioned that the last part of the workshop would be a quick discussion around what's next, like how you can use this tool, what other things we have to help builders. So you can host a subquery project locally. You can use other providers to do it, but you can also use our managed services if you decide to. Not every project has to be fully decentralized from the day zero. And then, of course, you can use our decentralized network to host your project as well. And this is a big part of our mission, to go fully decentralized and help builders to be truly decentralized and build applications which are decentralized, and to avoid single point of failure. Our marketplace decentralized network allows projects to deploy on the network and use the globally distributed network of nodes to their benefit. So it's not like a single entity, one company is performing the service for you. You have an access to the globally distributed network of node operators, which are not two entity, right? So this is how the subquery network works. It allows you to publish project in seconds, and then use other node operators to get this data index. They are paid or rewarded in SQT token, and you can seamlessly query it through Gateway and be fully decentralized. What we also did is that when we launched our network, we understood that we were in a prime position to actually address more issues related with decentralization in a Web3 space, and this is also related with RPCs. So we, as an indexer, you saw during my workshop, we were using a few endpoints. We heavily depend on the RPCs, right? This is our gateway to the blockchain data. We retrieve data from blockchain through RPCs. And we, as an indexer, work with many customers and 200 different networks, and we have this overview of different ecosystems, and we notice that they are fragmented. Not every ecosystem have the same variety of choices for builders when it comes to endpoints, to good RPC services. And it also, when it comes to indexing, you also want to have historic unpruned nodes. They're expensive, right? So that's the problem, and that's something that we wanted to solve, and that's why we also use the same network and processes we developed for a lot of things related with node runners for the indexing purpose. We also did it for RPCs, and we currently offer, there is already more than those, but a bunch of decentralized RPCs, and there is also a link to our website where you can check them out, use them in your application as well. If you need more information, inspiration, visit our documentation. A lot of good examples, articles, videos, workshops, videos like this one probably sooner or later will end up there. I have to finish, okay. And join our community, and let's stay connected. We are staying here longer, but of course, drop me a message. I would love to hear your feedback from you. And it was a pleasure. Thank you so much for your time. Complete the workshop challenge. That's the end slide. Thank you so much.
Thank you, Marta. Just in case, any questions from the audience? No? Well, this concludes day 2 of the Hacker Stage. From 7 p.m. onwards, we're going to have a cocktail event happening on the rooftop. So if you're in for some relationship and getting some drinks, please visit the rooftop and have a blast. See you again tomorrow.